Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. We have a great webinar on tap, as always, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on demand. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for either of our speakers, please don't wait, don't hesitate. Just use your GoToWebinar control panel and submit your question, and we'll try to get to as many as we can near the end of today's webinar. Also happening at the end of today's webinar, we'll be doing a drawing for 4 $100 Amazon gift cards. So please stick around. Hopefully you will be one of our 4 lucky winners. All right, with that, let's go ahead and kick off today's webinar, which is Protecting Data in Red Hat OpenShift, DevSecOps that scales with your Kubernetes deployments. Our speakers today are Tim Riley, who is CEO at Zettaset, and Maxim Yankowski, who is also with Zettaset. Gentlemen, thank you so much for joining me today. Really excited to have you here.
Yeah, thank you very much. Excited to be here.
All right, well, before we get started, Tim, I know you're going to be kicking us off, but before we get started, I actually want to turn things over to Michael Waite with Red Hat to say a few words.
Hey, thanks, Darlene. Can you hear me now? Is my microphone working?
Yep,
great.
Yep, you sound great.
I just wanted to thank Zettaset and Tim, their CEO, for being here. You know, our team works with software companies like Zettaset and others to make sure that their software is certified for use with Red Hat OpenShift, so customers can have ultimate confidence in knowing that when they want to deploy those solutions in a production environment, it's a fully supportable and thoroughly tested offering. And we like to spend money to help promote our partners and drive visibility for their technology, which is one of the reasons why we have Zettaset here today. Over to you, Tim.
Thanks, Michael. Thank you for everyone for attending. I just want to say before we even begin how great of a partner Red Hat has been. Over the course of the last 9 months, we've gone from doing our operator certification and the support we've gotten to get listed on OpenShift's marketplace, second to none. So thank you guys, you've done a great job. Real quickly on the speakers today, myself, Tim Riley, CEO of Zettaset. As I'm not going to read my own bio, you can tell I've been around tech and security and all the various levels, whether it's hardware, networking, security. So I've gotten a really good understanding of the market and where encryption and security as a whole fits as we grow commerce across all parts of the globe.
And I'm Maxim Yankowski, Vice President of Engineering at Zettaset. I've been with Zettaset for about 8 years now. And prior to that, I have various experience in different verticals, different industries related to computer science. And for the past 15 years or so, focusing on data security and encryption.
So he's the smart guy. Hopefully all the questions are at him. So I like to always start off with a little metaphor here. What this is for those of you who know it, that's Tower London. And what we have is William the Conqueror, just before 1100 came in, decided to build. And they continued to build another wall. And then they decided that's where all the currency was going to be made. So that is, in a sense, the value that protection will give you. And as it stands, just for your own edification, there's over $32 billion worth of treasure that is in there. That Star of Africa, I believe, in itself is $400 million. Now, all that said, something like that had a reputation of being impenetrable. Well, not too long after, look at that. Someone walked in, grabbed the jewels, albeit he got caught right before he left, but he was able to enter and get inside the walls and find a way to get to the treasure. The more concerning thing is just in the last 8 years, they've had 2 people get inside. So nothing in this world is impenetrable. And I think if you look at value versus a theft, it's always going to be there. I think it's been there since the beginning of mankind, and it will always be there. It's a cat and mouse game. So if we look, what is the value now? Yes, treasure, money, currency. It's all still extremely important. When we look at some of the biggest verticals out there, we look at government. They're tasked with protecting citizens. So there's attack vectors there. You look at financial, they protect our money. They are at the end, they are the commerce and what makes us all work in the earth, really in the earth. Now, if you add to that the healthcare, which is another one where all of our personal data resides. These are all extremely important, and all that is your treasure. That is, how do we keep that safe? And there are multiple ways to do it. You'll probably hear me say this multiple times. Security has many different pieces to it. I usually view it as it's a stool. There's the role-based access control or identity access management being one. The other might be the audit and monitoring and the integrity. And the third leg of the stool, which is always kind of at the back end, is encryption. Because if you get over the wall and you're inside the castle, what stops them from getting to the treasure? Well, encryption can actually keep that safe for you. And as we see here, now that data has taken such a monumental increase just in the last 2 years, 90% of data, that's phenomenal. And that is not going to stop. And as you can see, where the data is growing, yes, there's the social media aspect of it, which is big, and we all know how that is currently in the media. But more importantly, the sensors and devices that actually track, that's vulnerable. And of course, the enterprise data, which is truly the keeper of all this, needs to be protected. So as you can tell, look at where the zettabytes has gone. And there is the Zetta and the Zetta, so I think you can understand the name. But overall, you're going to see this continue to grow. Now, everybody will tell you this digital transformation we're going through in Kubernetes is definitely, they are the enabler of it. And for now, I think that we've seen that Kubernetes and Red Hat really is the focus. I think Red Hat has done a phenomenal job being a leader in getting their enterprise container platform up and running. And I think they're touching all the important verticals, and that would be public sector, financial, healthcare, and even the telco as they spread out to the edge. And Ashesh has definitely captured it with what he said not too long ago. I think it was earlier this year in a blog. And there we go. So where do we go from here? Digital transformation, the more aggressive you get with it, the more exposure you have. And I think it's wonderful that we've embraced it. I think it's wonderful that everyone sees the future being containers and Kubernetes. But as we go through this, the attack surfaces continue to increase because containers become more pervasive at the edge, on-prem, virtual, in the cloud, in the multi-cloud, the hybrid cloud, all the buzzwords. It's everywhere. Well, if data's moved everywhere, we need to protect the data. We like to say if you're managing the data, you also need to protect the data. So these are the key points for me. If you have security, it's important to understand it should not be an afterthought. I think, Maxim, what do you think as far as, from all your days of security? He was one of the guys who really put this slide together as the value points he sees, and I always like to hear his opinion.
Yes, thank you, Tim. Yes, security as an afterthought is a bad idea, but why is it such a bad idea? Because security is pervasive. As Tim mentioned, security needs to be applied in multiple layers simultaneously for it to be effective. And if you're designing and architecting a system, a complex system for that matter, and you start letting users in, the moment you open it up to users, you're opening it up to attack vectors. And securing the environment after is always a lot more complex than, think of it as building a house and then laying the network cables after the house has already been built and the tenants already moved in. It becomes a complex proposition. And balancing security and compliance makes it even more complicated because compliance is one of the strong driving vectors behind deploying security and behind deploying encryption. It has penalties associated with it. So you'd like to be compliant, even if security is not at the top of your mind. But compliance will bring it to the frontier, and you will need to address it. So the earlier you start thinking about security, the less of an impact it will have on your environment, and the less impact it will have on your users.
So just one thing to keep in mind as we go through, we do embrace Kubernetes in all of the different security features that are around it, and we think they're all complementary. And as we go through, obviously some of you know about secrets and passwords that comes with some level of Kubernetes. It's one aspect of it. It's not protecting the data, it's protecting the tokens, it's protecting passwords. So we understand that, we embrace it, we're just complementing and enhancing it, okay? I'm not gonna read my own quote. So when we look at where this is, cloud native CNF, Red Hat security report, I think Red Hat's done a great job on keeping it current on what they see as issues, what they understand is what needs to be identified as problems that need some kind of solution. And I really do think they captured it in their last 2019 report. If you're going to make that hybrid cloud, there's installations, that migration, you're going to have new attack surfaces, absolutely. And we're still learning, as the bad actors are learning just as quickly, where those vulnerabilities are. So we have to admit to ourselves that no matter what, there will be some kind of breach. And nothing is 100%. Go back to the Tower of London. Nothing is completely impenetrable. But if there's one additional layer of protection, you can give it is encryption. And you can see that over half understand that. They understand that, okay, it's more important that we have some level of a last line of defense than nothing. If I'm just pushing on integrity, if I'm pushing on passwords, if I'm pushing on monitoring, again, someone can get over the wall. Let's just put encryption in as well, okay? And as we can see, I like to show this one, and you don't even need to read it. Just look at the visual as we have growth in containers. You can see things move over, and look at the 1,000 to 499 and the 5,000 and up. Those last two, up 15%, up 19%. We are seeing growth. We're seeing further adoption. The value that we all know comes with containers and Kubernetes has really started to gain traction. It is early still. The market is maturing, and we all see the future, and everyone in the industry and every different distribution of Kubernetes can give you plenty of value props, and it's there. It's not going to go away. I think we found the next evolution of how to bring value to the customer. With regards to data containers specifically, Maxim does a good job. He was one of the creators and designers of the container and Kubernetes encryption product. And this slide gives a very good focus on where the issues are. Go ahead, Maxim.
Yeah, if you look at the challenges with deploying containerized environments, and as Tim showed just in the previous slide, the environments are growing in size, and the sensitive data is being pumped into environments for the purposes of analytics. You will quickly realize that security is the top concern for processing sensitive data in containers. One of the other concerns is, of course, unauthorized access, but really, before you even go into the land of, is a user authorized to access data in a container, you need to make sure that the container is secured, and you need to make sure that the container data that the container is accessing, that the data is secured as well. So data protection in containers, top concern.
And again, you can just look at the graphic, look at the colors, look at the size. All of those things are important, and there's wonderful partners and other contributors that bring you those tools, but at the end of it all, it's the data. The data needs to be secured.
So how do we actually, now that we talked about the growth of data, now we talked about the complexity of an environment and the enterprises driving their data to those environments, and introducing the new attack vectors, how do we actually apply all of that, and how do we apply our knowledge of encryption and security and data protection to make sure the environment is secure? There are three fundamental things when we talked about designing with security in mind. There are three fundamental things that we need to be aware of. First, containerized environment created or give rise to shared storage. Containers don't just attach to hosts. They usually run dynamically, and they usually get scheduled based on the load of the cluster. Consequently, when the data container comes up, we need to make sure, the environment needs to make sure that the container can access this data. So if it comes up on a different node, it cannot use storage attached to the node. It needs to use the shared storage. Therefore, if we were to secure the data at the storage level, we must make sure that encryption will follow the storage. So whatever the data is, the data must be encrypted. Because containers move around and need to access storage from different nodes, the storage must be independent of hosts and containers. Wherever container comes up, data is there. Last but not least, the whole purpose of, well, one of the important purposes of Kubernetes is giving developers and engineers an ability to deliver products and deliver value quickly and efficiently. You don't want developers and engineers to make decisions about what kind of data they're dealing with. You don't want developers to decide if the data is sensitive or if the data doesn't need to be protected. So you need to maintain a clear separation of duties of who decides what sensitive data is. And the easiest way to do this is just to basically say developers will work on the environments, administrators will make sure the environments are up and running, and data will always be secured throughout the enterprise. So this is all nice and well, and encryption has been around, for ages, or for a long time at least. So why isn't encrypting data? Why isn't that been adopted as kind of a widespread approach to data protection? Because we talk about encryption just about as much as we talk about data breaches, and data breaches occur more frequently and become more costly. So why isn't encryption being adopted? For years, we've seen, and this is especially true in the past 3 years, and as environments become more complex in scale, system performance and latency is at the top of the concerns. Because encryption is great, security is important, but if you introduce a technology into your environment and it slows down your environment to the point of not being usable or not being able to derive value, that's a non-starter. Policy enforcement refers to an inherent or sometimes perceived complexity of encryption deployment. You deploy encryption and suddenly the users comes in, nobody can access their data, they have to go change their passwords, they have to contact security admins, and it quickly becomes a nightmare in the enterprise. And so I'm not going to walk you through all the 6 hurdles. Suffice it to say that when we were designing our encryption products in Zettaset, we really looked into those hurdles and say, we're going to address those, all of them, and we're going to make encryption and security so easy to deploy that nobody will have any excuses not to deploy it.
Yeah. And I think we just bring it back to what we've covered so far. Massive amounts of data being created. Digital transformation is seen as a way to take advantage and extract value. Kubernetes and containers are seen as a main method to do that. Well, we have container growth moving into production. Data is at risk. Now, what are the main things that data needs to have for safety? And top one is encryption. How do you deal with the encryption drawbacks? It really comes down to encryption. It's a calculation. There's back and forth, and the concern is always performance. It's depending on the technology and depending on where you are, it could be upwards of 66% performance impact. I say we'll get into this in a little bit, but it's important to say Zettaset has been able to reduce that to 2 to 5% performance impact, and that really is the value add to what we have right now. And this is, in my mind, one of the most important pieces of it. You can see there's plenty of other partners, there's plenty of other infrastructure vendors, but some of these are pretty much the main players, as we all know, household names. What is important here is you may say to us, well, we got encryption covered on this level. We have it covered on this level. Is there any kind of unified policy and distribution and protection across all these environments? That's a challenge. And the more data moves and the more Kubernetes containers are put into production, the attack surfaces continue to grow. And one may be on the edge. Another entry point may be in a cloud. Maybe someone's misconfigured it. Maybe there's a bad actor. Somebody goes into the data center, comes in through virtual. There is a multitude of different levels that encryption can be applied to protect data. And Zettaset has viewed this as, can we bring it all together? Can we manage, regardless of where the data goes, can we encrypt it? And we have a product line that can do that. Specific to where we're talking about today, the future is in the virtual world, as you can tell, with Kubernetes and containers and with Red Hat, and we feel we're really enabling the further scale out regardless of the vertical. Okay. Now, here is what I view as moving to DevSecOps. We haven't really even said the DevOps word yet. DevOps is synonymous with containers. It's synonymous with Kubernetes. And to where we need to go, because again, we've rolled out all these great technologies. The value add is there. Sometimes new technology gets so quickly adopted and pushed out, we forget about security entirely. And as we said before, you need to keep that in mind. Whether you do it at the front end when you design, or even after the fact, before you have some kind of incident, there's a breach and a theft, get ahead of it. And for us, DevSecOps, and I'm sure you've heard it from other DevSecOps vendors, this is where we are right now. To get that next level of adoption in the technology, you must have established security, and that involves encryption as an important part of it. So how do we do this without impacting the business operations, which is what everybody has to avoid, whether it's access and passwords, monitoring. If you slow down commerce, if you slow down the ability to find value, you're going to have an impact, and there's going to be hesitancy to adopt. So when we can do this with real-time Kubernetes encryption, therein lies one check the box you're done with. Well, if you have to deal with data, you need to have it so the data is just presented to the developer. They have no idea that it even was decrypted behind the scenes. They just have it there. So you are truly transparent to the end user. Again, I will hit on this a bit. You really need to have near zero impact if you truly want to be embraced by your full IT and your CISO across every piece of data that's everywhere in the world, of multiple data centers in the cloud or at the edge. You can't impact it too much. If you do, they're not going to adopt it. Okay.
And to add to that, we're dealing with essentially an infinitely scalable systems. We're beyond the world where we used to call a system admin to provision us a piece of hardware and a storage device and chunk of memory to be able to run the application. Now we have constructs like Kubernetes operators that are essentially provisioning applications on demand. Application instances scale up and down. Storage scales without humans ever touching the system. So we need to have encryption and protection technologies which will scale with an environment. And hardware encryption are going to scale. So you're essentially looking at a software encryption solution that will scale with your environment, and as Tim said, will not introduce performance impact.
And if you've been thinking, well, what exactly do you provide? Yes, it's data at rest and data in motion encryption. Zettaset and Red Hat, this was something that was very apparent to us as soon as we understood the importance of DevOps and how we needed to migrate to DevSecOps. We've had conversations with Red Hat, the OpenShift team, for 9 months, and they saw the value. We saw the value of being able to protect them as they scale out. If we can help to scale out with the DevOps and the applications that need to grow and the enablement that OpenShift's platform brings while protecting it, there's a marriage there that's an obvious one, and any way we can help with the proliferation of OpenShift, we feel we need to do that for you. And if that happens to be across any type of environment, we understand the value in Kubernetes, whether it is in the public sector, it is financial, the telecom, or the healthcare. These are important areas where the data needs protected if OpenShift and Kubernetes is truly going to add value. Where we can go with this, I think I've said it, I just put the visual up here, regardless of where OpenShift touches. And I think we've all seen the use cases and already where the adoption happens with the household Fortune 500 names that really are adopting this to extract value. Wherever that data goes, which it will within a container, we're able to protect it. So as Red Hat scales, so will we. And I think we've hit on these, but we like to at least pull all the bullet points together for you. Like we said, performance-wise, we can have near zero impact on it. We're going to encrypt data, whether you want all of it or a selected one. We have that option for you. And we'll give you the level of granularity that you need, and we'll get into that in a little bit. One of the things we didn't talk about is it can be a little intimidating to use crypto. Not everybody is a crypto expert that came with a PhD. There's no worry about that. We have the ability, we've made it automated enough where it's easy enough for any IT management to deal with. I think that's important because if you point and encrypt, you need to have peace of mind that you're covered, and with the automation, the deployment and installation is taken care of. Because we all know when you do that, a lot of times, and there's plenty of examples in the press, whether it be with AWS or another cloud provider where something might be misconfigured, the automation and deployment allows you to have peace of mind that you actually did it correctly. Do you have anything to add on these?
Scalability, we talked about. The environment needs to scale, so the encryption needs to scale. And also the types of environment we're dealing with, hybrid environments, on-prem, cloud, any sort of environment, any mix of those, the encryption solution needs to apply to all of them. We're not giving you an encryption solution that will require you to buy additional encryption solutions. We're giving you a self-contained, complete product that will give you data at rest and data in motion security. In contrast to other encryption technologies such as self-encrypting drives, for example, we give you the complete package. Self-encrypting drives may perform well. They lack key granularity. They lack understanding of the environment they're actually encrypting. They're not providing any data in motion protection.
So, and let's wrap it back up to the whole theme here. We've told you why encryption is important. We've told you the value that we can provide to OpenShift and further in their deployments. But there is a huge compliance piece of this. The adoption across any type of regulatory, it doesn't matter. Globally, we have it, whether it's GDPR, whether it's FINRA, whether it's HIPAA, whether it's any type of compliance that's out there. And we just have all seen that it's not going away. The bad actors, criminals, rogue nations, all of them are looking to target and expose data. We are definitely at the forefront with Kubernetes, but we have to be at the forefront with encrypting that data if we're going to continue that expansion. And to do that, you have multiple levels of encryption. And remarkably so, I don't think everyone understands that just yet, but they are quickly being educated. I view it as, I like to look at it as the iPhone. The iPhone, when the encryption really got spotlighted in the last few years, what we all know is you put in your password and you know you're encrypted. It doesn't impact performance. You know the data is safe. We feel the same way about it. Maxim, in fact, has a great saying that if we make encrypting everything so simple, why wouldn't you just encrypt it all? And that's what we really wanted to do, is take off any of the resistance to want to adopt encryption.
So what are some of the advantages of the native container encryption? And first of all, why do we do it natively to begin with? So if you look at migrating your legacy or existing application to Kubernetes, the first thing that Kubernetes documentation will tell you is that don't just take a legacy application and put it in a container. That's not going to make it run faster. That's not going to make it run better. It's just going to be the same old legacy application running in a different infrastructure. What you need to do, you need to really go through architecting the application to take full advantage of containerization framework and multi-tenant container environments. We, in the spirit of containerization, we have done the same for our encryption technology. So all of our encryption services, they all run in containers natively within Kubernetes. What they provide is a completely transparent high-performance encryption solution, which is also intimately aware of the Kubernetes environment where it runs. So we will talk about storage volumes at greater extent later in the presentation, but it's important to note that every storage volume that container is requesting and every storage volume the container is attaching to in our solution will be encrypted with a unique cryptographic key. That's of paramount importance when we start talking about multi-tenant environments. And multi-tenancy is really one of the hallmarks of Kubernetes environments because that allows you to derive so much more business value from a shared Kubernetes infrastructure. Secrets, they're great constructs for protecting passwords. You can protect certificates. You cannot establish data protection methodology using Kubernetes secrets. They're an important tool in the tool belt, but they're not enough. And so once you deploy a proper encryption infrastructure with Zettaset, you will have additional benefits such as an ability to securely erase the data. One thing that encryption vendors often don't talk about is that once you're done with the data, what happens with the sensitive information that's stored? And to securely erase the data was always a tough proposition, even at the time of traditional hard drives when people had to drill holes in the hard drives physically. Right now, it's not even possible because your hard drive may be in the cloud and is likely in somebody else's data center. So we have ways to securely and cryptographically decommission or erase the data, sensitive data, after the data is no longer in use, without you having to access physical environment where the data is stored. The same applies to compromised nodes or the nodes that are taken down for the maintenance. With a simple cryptographic operation that an admin can execute at any time, the nodes will be cryptographically removed from a cluster, you don't need to have access to the node. The node doesn't even need to be up and running, but it will instantly lose access to sensitive data. Last but not least, storage separation. We talked about shared storage. Shared storage is a blessing when it comes to containers running in different places. It's a major difficulty when it comes to how the data is accessed when the data is of a sensitive nature. So if the storage is shared by containers and containers store sensitive data on that storage, that sensitive data should not be shared by other containers. What we're doing is we're physically separating storage volumes that are allocated to different containers so that when the container stops, the storage volume is no longer accessible at all.
I would say that there's plenty of slides in this presentation, but this one is of the utmost importance because it really does identify the value of where you put the encryption.
The way we were building that solution is we really started with understanding of what the container storage model is. And we quickly figured out that naturally, if we would like to encrypt and secure container data, we need to do it at the storage level. We should not trust the infrastructure to do that, although there are plenty of articles flying out on the web that say, just trust the infrastructure, you're putting the data on Amazon, just trust the Amazon Web Services to encrypt your data. That is wrong on multiple levels. You need to own your data, you need to own your keys, and trusting cloud provider with the data and the keys at the same time is just bad security. So how do we encrypt the data on the storage level? We integrate directly with container storage systems. In Docker, that includes native integration with Docker Volume Driver. So that's where we started. Then we started looking at Kubernetes and figured out that Kubernetes model, the storage model, while similar to Docker, is a lot more advanced. So we've created our own CSI driver, container storage interface driver, that integrates directly into Kubernetes and provides native storage management. One of the benefits of doing that, although the solution becomes a little bit more complex, it has a big benefit that the container that actually stores and manages the data does not need to have any encryption software in its container stack. So containers are still lightweight, or as lightweight as you can make them. We don't increase the memory footprint. We don't increase the container image footprint. All of the encryption is taken care of by the containers. Enter OpenShift and Kubernetes operators. So now you can deploy the entire encryption solution with all the services which are required to enable data protection. You can deploy it with one click from Red Hat Marketplace with OpenShift operator. And as was mentioned at the beginning of the presentation, all the container images are certified by Red Hat, all pass rigorous testing, and the operator itself is certified and guarantees that the images are not only secure, but also tested and verified.
And this comes back to one of the best value props I think OpenShift has, that it's hybrid. It doesn't matter where the container is, the platform can manage. And you can see we wanted to show in this slide that it comes from the bottom up. Regardless of where it might be, we're able to have that native encryption that follows.
Hey, Tim, this is Mike from Red Hat. Just there's a question that came in. I thought maybe I'd just toss it out there, see if you folks wanted to read. It just says, what DBMs are supported, and does it support big data lakes?
So because we run in the storage system just underneath containers, and containers are not really aware of the fact that their data is even been encrypted, but we're on just atop of the Kubernetes storage subsystem, we can encrypt any storage that's essentially attached and provisioned by the infrastructure.
We may also have another slide that may
we actually
talk to
this. Yes. Right. So where we are in that question is actually a good segue into where we are. We're just underneath with the encryption engine. We're just underneath the file system. We're inside the file system stack. All the read and write operations are intercepted by our kernel module that runs on every Kubernetes worker node. That module is transparently encrypting data that's written to the devices and transparently decrypting any data that's been read from the encrypted devices. Because we integrate with container storage interface, we have implemented our own persistent volume and storage class and persistent volume claim objects. So all you need to do is to take advantage of the encryption, assuming Zettaset's already deployed a new cluster with the operator. All you need to do is to request a storage of type Zettaset encrypted volume, and you get full benefit of one-click deployment with the operator. You'll get certificate authority infrastructure to make sure all the services talk securely, and you get an enterprise key manager that runs natively in Kubernetes cluster.
So one of the case studies at this point, I'm sure we're looking at it, is how pervasive is OpenShift, and I think we're all aware of the financial benefits for the financial industry within it. And there's going to be a theme. The theme, regardless, is if you're adopting a Kubernetes or specifically an OpenShift platform, every different area will have security for sure. And as we've shown before, the security offerings from other Red Hat partners, it really complements it. But at the end of the day, there is one area where we really want to enhance the data and the protection, and that's really around the container and what the container touches. Because if you don't have that, you really do have a concern of breach and theft. And this will be the same when we show you a government one as well as a healthcare one, that depending upon what the vertical is, there still is the various sensitive personal data that's out there. We all know what happens with that. There's fines. There's the public concern about the security. There could be loss of revenue, business interruption, just the cost of dealing with that. It doesn't matter what the vertical is, but compliance is huge in these type of environments. And to be able to enable encryption, it gives you that additional level of regulatory compliance that I think is understated, but will become even more of an important feature going forward. If you can do it regardless of the vertical, if you can bring encryption without the impact, without the performance, it's transparent to everyone, you're going to have further adoption. And because of that peace of mind, you will further be able to expand where OpenShift is used and how much data it touches. So out of all this, we like the little animation here. What it's showing you is the bad actor went over the wall, and we back to the Tower of London. And all of these solutions that we have around do a wonderful job. A lot of the other partners that work with OpenShift do great things. But again, 99%, nothing's ever for certain. If a bad actor does get in, they then have access to all the various pieces, all the houses of data that are within that storage. What we're able to do with the Zettaset solution is close those and then protect them with encryption. So now the house is safe. Even if the bad actor is there, it doesn't have access to the data because all they have access to is encrypted. So these are important pieces, and I think this is very representative of what the Zettaset brings, where the value add is, where I would say the ability to enhance what encryption or what security is there. As you can see here, great partners with regardless of what kind of security, whether it's monitoring, whether it's remediation, all of the various pieces of security. All those vendors are really focused on Kubernetes and the node and the pod and the containers, which is essential. And on the bottom side, you have a lot of the vendors with legacy shared storage. And again, they are great, but there's one problem. As we now have migrated from legacy into this new DevOps world where Kubernetes has a distributed nature where you're touching hybrid clouds, multi-federation, there is no end to where a container or pod can pull data from. Just in case you're not aware, the data will come from a persistent volume, which is on some kind of shared storage. And if the shared storage, again, something leaps over the house, all those persistent volumes are exposed, and the wealth of data that normally would only be separated are now accessible to any bad actor. So as you can see, what Zettaset brings is that new level of Kubernetes solution whereby each one of those is encrypted. You could have hundreds of persistent volumes being tapped by 1,000 containers. One bad actor, one container gets access within the encryption, and you have a massive data breach and potential for theft. You want to add anything to this? We're usually
Yeah, what Zettaset really adds is a storage protection that's granular enough to protect your multi-tenant environment. Because one compromised container, if you're not deploying encryption the right way, one compromised container will compromise the entire environment. As Tim mentioned, the focus as of late or as of currently is really, the focus has been on protecting container images, protecting container infrastructure, making sure the software that runs in the container is secure. Well, we keep asking, what about data? Isn't the data the ultimate commodity, the ultimate price possession of the enterprise? What's been done to secure the data? The answer we often hear is that just trust the infrastructure to secure the data. Infrastructure is not granular enough to understand containers. And because it's not granular, it's not able to provide the same level of key hierarchy, and it's not able to provide the same level of protection. So with Zettaset, you get every persistent volume encrypted with its own unique cryptographic key. So if one of the persistent volume is compromised, other volumes will be secured because they're not sharing the keys.
This is fundamental to expanding Red Hat and OpenShift, because we all know that there is no homogeneous environment. It won't all just come from AWS. It won't just come from vSphere. They're going to be, and maybe you feel comfortable with the encryption in some of those. That's fine, but we all know that you're going to be touching data that's stored in various type of environments. It could be in the cloud. It could be on the edge. When you suddenly go outside one of the storage vendors, can they span across all those environments? And the answer is no. And that's where we are able to come across all of those, give a consistent policy, and give you protection of the data with encryption across any one of those environments. Okay. So I think this is a great slide to show you how Zettaset adds value to all those other great vendors out there that are providing security. I encourage you, hopefully if you have some level of Kubernetes or OpenShift, these are important pieces. But there again, if you notice the data piece of it, that's where we come in. We feel that it's very complementary to what else is out there. I think all the pieces of the puzzle here, there's multiple vendors obviously in each space, but these are what I consider the big seven of what you need for a true security solution around your Kubernetes and your OpenShift environment. And in all instances, we're able to take care of the data. We love the fact that everyone else is taking care of the containers, but we'll take care of the data for you. Okay. And again, here is another similar study that we have with a federal agency whereby you need to have citizens' data protected. I think the time to value that you'll see with any one of these deployments is the benefits far outweigh the risk if you can have the encryption in place to minimize that risk. And I really do believe that regardless of whether, again, it's the monetary value of personal data or the citizen value, they're just as important. All three, including healthcare, you need to protect that data. Expand your Kubernetes and your OpenShift deployment wherever it has to quickly give time to value for the customer to have a competitive edge with your innovation. But if you're going to touch data, we have you covered. Okay. So I'll let Maxim talk to this, but this is an important piece because at this point we've talked to encryption. We've said it's great. We've said we've got all these fantastic things. But most of you probably have heard of encryption. You've heard of different forms of it. And really, this is what these three boil down to, and we'll tell you why this is the most optimal. I almost call it the Goldilocks.
Yeah, encryption has been around for many years, and it's taken different shapes and different forms. And of course, as Tim mentioned, encryption needs to be transparent to be effective, because you don't want encryption to impede your business. So what's the ultimate level of transparency, or at least the perceived ultimate level of transparency? You put a self-encrypting drive inside your server, and as the definition says, it self-encrypts. It encrypts the data on the drive without you having to do anything. Well, usually when you give that level of control to a software or hardware platform, it needs to make choices and do things a certain way in order to accomplish its task. So you give away control, you give away granularity, you give away the ability to control the environment. You get one key per entire drive in most installations. Enabling multiple keys is extremely complex and doesn't always work. There's no policy management. How do you manage 10,000 drives in 100 nodes? What if your environment scales to 10,000 nodes? Self-encrypting drives, great tool for encrypting data in your laptop. Not so great for encrypting data in the data center, and in the cloud, forget it. You don't even have control over what kind of self-encrypting drives are deployed, if any. And of course, once the data is off the drive, there is no protection. Seagate and other players will tell you, well, you need to have data in motion protection, additional solution in order to protect data once it leaves the drive. So is it simple? Yes. Is it secure? Not so much. So now we're starting to talk about file encryption and folder encryption. Again, technologies that's been around for quite some time. This is where, again, there's a certain level of transparency. There's a certain level of granularity that a lot of people will tell you that, this is sufficient because it's transparent, but it's also granular. However, that's not the level of granularity. Kubernetes will store persistent volumes ultimately in files, but file and folder encryption will not be able to tell you what persistent volumes those files relate to. In addition, most of the file and folder encryption solutions need to communicate with key managers so often that the performance overhead is just going to be enormous. So you're going to have an additional complexity of file and folder encryption, but you're going to pay dearly with performance. What we're doing with Xcrypt full disk encryption software is we're encrypting close enough to the storage so that the performance overhead is minimal. We don't talk to key manager nearly as often as file and folder encryption, so we are essentially running entirely in the kernel space, and therefore infrequent communication with the key manager don't create network bottlenecks. Key and policy management is entirely automatic. You deploy us with what Tim correctly called point and encrypt, and after that we take care of key rotation, we take care of protecting your data, and we take care of appropriate key granularity, where every partition or every storage device or every persistent volume will get its own cryptographic key that will not be shared by anything in the system.
Great. So just to repeat, I like to show this one. This is a multi-cloud federated hybrid cloud, however you want to look at it. And in this instance, looking at the bottom, you can see that it might be an extreme case, but these are 5 different types of shared storage with 5 different vendors. Each one of them is protecting their storage, which makes all the sense in the world. Within that, you can see the persistent volumes are open. So if you get through that one key, you have access to everything like we had said before. So this is the struggle, especially if a container, one container, is accessing more than one shared storage across more than one vendor, maybe on cloud and on-prem. So the exposure points are there. So how can we help out? Well, we can give you across all of these different platforms the ability to assign encryption to each one of those partitions. So one key for one container. And when you see this, you can understand how a bad actor then all of a sudden is limited to how far it can get into any kind of shared storage, how many persistent volumes it can touch, and how important this is. Otherwise, you may find out that a bad actor has gone across 3 different shared storage vendors and had access to terabytes of data. I think we're going to finish up just by talking to the health one that I think most people at this point understand the importance of personal health information. That HIPAA, albeit it doesn't explicitly request encryption or demand it, we all know it's important enough that it's there under the covers. When it comes to healthcare and provider deployments, you're far-fetched to have any type of missing encryption at the base legacy level. Now here we are starting to see the expansion into, again, this new DevOps world and Kubernetes and benefits of OpenShift. And with all the telehealth, and especially considering the current environment with the pandemic, you now have more data, personal data, going back and forth. And the exposure of containers that may be dealing with hundreds and hundreds of patient data, there is a higher risk. And in that case, encryption becomes all the more important, especially in healthcare. Finishing it up, I do believe that if we want to see OpenShift continue to be adopted as much as we've seen it, we really do have to have that there's confidence and that we have the ability to drive innovation and protect the data while we're doing it. The security breaches will be there forever. They will always be in some level, but can we mitigate it? Can we bring that down to less than 1%? Well, yes, we'll try, but in any event, you need to have encryption that's going to mitigate that even further. If there's a breach, you can minimize any amount of data theft with encryption. I think it's important that we understand that developers shouldn't have to worry about this. This shouldn't be a burden that's carried by the developers. This is something that the security, the IT infrastructure should be able to handle, and with this encryption abilities that Zettaset brings, we give you that level of comfort, and because it's easy, there's enough ease of use, you don't have to be the crypto expert to do it. So with all that in, maybe you've already deployed DevOps, and we can give you a smooth transition to more of the DevSecOps environment with encryption. Again, it's not the only thing, but it is an important thing. And just to bring it home, we've been on Red Hat Marketplace since the virtual summit at the end of April. Very happy to be part of that. We just announced last week, and proud member of the security section of that Red Hat Marketplace. As you can see, there's what it looks like. There's our tile, and if you're interested, we will be giving this this deck out. I know it'll be distributed after the webinar, and there's a link directly to the Zettaset product. Thank you. I think we covered quite a bit, and would be happy to take questions now.
Yeah, we do
Tim,
have a few. Go ahead, Michael. Go ahead.
I was going to just bring it up. There was another question that came in from Don. It was, is Zettaset encryption, quote, quote, at rest and in transit?
Zettaset Xcrypt portfolio addresses both at rest and in transit encryption. That's correct. And all of it runs natively in the container and Kubernetes environments.
All right, great. We do have a few minutes for questions. So if you do have a question for Tim or Maxim, please go ahead and use your GoToWebinar control panel and submit it. Here is another question for you guys. Why not just use self-encrypting drives?
Great question, and we covered it to a certain extent. Self-encryption drives, to make it short, great for laptops, not so great for data center and cloud and larger deployments, mostly because they just lock the key management aspect. We didn't talk a lot about key management during this presentation because we don't want you to worry about the key management. We take care of it, but key management is a very important aspect. Self-encrypting drives severely lock on that. They usually trust encryption they usually trust key management to the operating system. Not a great idea.
Gotcha. Okay. All right. Here's another question for you. How do you approach key management in container environments?
We have key managers that runs natively in containers. It will scale, quote unquote, infinitely as the environment scales. We also make sure that we're giving you an ability to integrate into existing infrastructures, because if you're an enterprise, a sizable enterprise, at some point you were faced with certain regulation or you needed to secure your customers' data. So maybe you already have investment in security technologies. Maybe you already have key managers in your environment. We're giving you a self-contained product with key management included. We're also giving you an ability to integrate with your existing key managers and security modules.
All right. Great.
The way to bring it home, the way you approach key management in containerized environment, you run natively in containers, you run software-based key managers that scale with the environment.
Okay, great. Next question here. If a customer wants to provide their own encryption key, is that an option?
It certainly is an option. However, there were numerous research studies done that encryption key management is kind of transparent, but quite a complicated proposition to have the customer take into their hands. And bring your own keys usually been touted by cloud providers to give you an illusion of control. You can bring your keys to our system. However, we're more than capable of creating the keys and managing the keys. Generating cryptographic keys is not a simple exercise, and it's usually delegated to the key managers. So can you bring your own key to our key system? Yes, you can. Do you need to worry about it? We've actually gone to a great extent that you don't need to worry about that.
Okay. All right, great. Well, we are about 5 minutes to the top of the hour, so I'm going to go ahead and close out the question and answer period. Thank you to everybody who did submit questions. I think we got to them all, but if for some reason we didn't, or if you have a last minute question you want to go ahead and put into the GoToWebinar control panel, please feel free to, and please know that the folks at Zettaset are going to get a copy of all the questions. So if you do have one of those last minute questions you want to go ahead and put it in, I'm sure they'll be more than happy to follow up with you offline. Also want to remind the audience that today's event has been recorded, so if you missed any of it or if you want to watch it again, you'll have the opportunity to do so. Following today's webinar, we are going to be sending out an email that contains a link to access the webinar on demand. And the webinar is also going to be living on the DevOps.com website, so you can always go look for it there. Just go to DevOps.com/webinars, look in the on-demand section, and it should be right there waiting for you. Okay, I mentioned at the top of the hour we would be doing a drawing for 4 $100 Amazon gift cards. So without further ado, let's go ahead and do that. Our first big winner today is John S. Congratulations, John. Our second winner today is Melissa T. Congratulations, Melissa. Our third winner today is Don K. Congratulations, Don. And our final winner today is Jason L. Congratulations, Jason. John, Melissa, Don, and Jason, please check your inboxes for information on your Amazon gift cards. If you don't see something in your inbox, then check your spam filters. Tim and Maxim, thank you so much for a great presentation. Lots of really, really fascinating information. So thank you for your expertise, for your time, and for sharing with us today. Really appreciate it.
Thank you very much, Charlene.
Thank you for having us.
Glad to be here.
No, you're welcome. And also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I'm now signing off. Have a great day, everybody, and please stay safe.